Hello everyone. In this video, we are going to learn how to find definite integration, which is of a function integrand involving special functions like integral part function, fractional part, and a modulus of x type of functions. These three are very crucial in the JEE preparation. So most of the questions related to including these three functions. So we should know how to convert them into algebraic form. Okay, and after that we have to apply linear integration over that. So here I'm dealing with a few questions which is involving these three functions in definite integration. So let's look into the first question. So more such videos on definite integrations and complex numbers I have already shared in my previous videos, so you can please go through that. So here let's look into this integration. First question, integral 3 to 10, lower limit is 3, upper limit is 10. So before we enter into that, let's see that how generally we do convert these special functions into algebraic. If you look at modulus of x, the definition of modulus of x is plus x, means you will replace mod x as x if x is a positive quantity, and you will replace mod x as minus x if x is a negative quantity, and it will be 0 if x equal to 0. Unless we convert these three functions into algebraic form, we may not able to apply integration, or we may not able to do differentiation also. So for both of that, we need to convert them into algebraic form. Next, how do we convert integral part function? Integral part of x is defined as greatest integer less than or equal to x. For example, if x is between 0 to 1, then the integral part of x becomes 0. Okay, if 1 lie between x and 2, the integral part of x becomes 1. Of course, lower bound equality there. So suppose if it is 2 less than or equal to x less than 3, integral part of x becomes 2. Means as long as x is between 2 and 3, the value of integral part becomes always 2. So you can replace integral part with 2. This is how we do convert a step function. Next, coming to fractional part function. The fractional part function definition is x minus integral part of x. So as 0 less than x less than 1, then fractional part of x becomes x minus, because integral part of x is 0, for 0 to 1 it is x minus 0, so it will be x. If 1 less than x less than 2, then fractional part of x can be written as x minus integral part of x is 1. So like that, between 2 to 3, then fractional part of x can be replaced by x minus 2. So this is how we do convert these three functions into algebraic. Okay, this is the basic idea. Now come to here. So limits given are 3 to 10. So these limits are for what? Yes, these limits are for x. So 3 less than x less than 10, if you take it. Right. Then integral part of x. What are the possible values of integral part of x? Means it can be 3, 4, 5, so on up to 9. So here that the log is given here. What is the base of that log? By default in GE, mains or advanced, if nothing is mentioned, we have to assume that the base is E. What is E? E value is an infinite series, 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial, so on infinity. So approximately this is 2.7. Right. So since the value of E is 2.7 and the limits are from 3 to 10, so that means here E is less than 3. Okay, and this integral part of x, whatever the possible integral part of x values means 3, 4, 5, 6, 7, 8, 9 only. So e square value. So e value is 2.7. E value is 2.7. Then e square will be approximately, it is it is e square value is 7 point approximately 7.29. That means it is less than 8. So e square is less than 8. So our discussion is 3 to 10. So in the first case we divided the 10 to 3 to 8. We have divided. So between 3 to 8 we can insert this e square and 7 value also integral part of x. So finally integral part of x can be from 3, 4, 5, 6, 7, because it is strictly less than 8. If integral part of x is between 3 to 7, then log of that one means log of that, the values are between e to e, so e less than integral part of x less than e square. Now if we apply log on both sides, because the base is e, inequality will not change. So log of e to the base e less than log of integral part of x to the base e less than log of e square. So this will be 1, this will be 2. So it lie between 1 and 2. So log of integral part of x lie between 1 and 2. Then again one more integral is there, integral part is there. So there are two integral parts. So that integral part of this expression will be 1. Fine. Next, suppose the case 2. Suppose that x value lie between 8 and 10. Then what are the possible values of integral part of x values? Means 8 or 9 only. Only two possibilities. So e square is less than 8 and e cube value is more than 11. So what you can observe that here, that log integral part of x value lie between e square and e cube. So if I apply log on both sides, 2 less than log of integral part of x less than 3. So that is what this one. So integral part of that value will become 2. So finally, that a total integral 3 to 10 we divided into, so 3 to 8 first case and 8 to 10 second case. In throughout the value of x between 3 to 8, the value of the integral part of log of integral part of x value is 1, and that throughout that 8 to 10 the value is 2. Then we can apply the different integration and we are getting the value 9. So this is such a good question, like it will brush up all your basic ideas of applying it, how to use integral part in different integration. So the main task here is that where you will break the interval, where you will break the interval so that you can separate that values, you can find rewrite the values of integral part as some value. So here let's look into one more question based on absolute value of x. And the question here is that minimum value of f of x is a function which is the minimum value of three functions is given: mod x minus 1, mod x plus 1. Then the value of integral minus 1 to 1 f of x dx is how much? So if you if you draw the graphs of all the three functions, mod x, mod x graph, this is mod x graph, and modulus of x minus 1, this is modulus of x minus 1, and modulus of x plus 1, this is modulus of x plus 1. If you look at these three graphs, so finally we are talking about that minimum values of all this. So the minimum values of all this, and that what is that limits for f of x given? Minus 1 to 1. So this is minus 1, this is 1, and this is 0. So between minus 1 to 1 only we are talking about minimum values. So which part of the graphs are being considered to be minimum here? This part, here, and here. So only that part is the minimum value between minus 1 to 1. Right. So now it is simply area, two triangles you are getting. So you actually you have to find out in definite integration. Instead of definite integration, you can find the areas of the two triangles, and both the triangles are symmetric about y-axis also. You just find out one area, and that will be twice of 2 into half base. Half is base is 1, and the height. So height means this line is mod x graph, and this line is modulus of x minus 1 graph. If you equate them, if you solve them, so you will be getting 1 by 2. So you'll be getting this point as 1 by 2. So this is 1 by 2. Height is also 1 by 2. 1 by 2 comma 1 by 2. So half base is 1, half base is 1, and the height is 1 by 2. So this comes out 1 by 2. So the total different integration, this total area, this area plus this area, total is 1 by 2. So this way also, like using graph also, we can calculate the definite integration. So there is sometimes that area, it is easy to calculate area rather than definite integration. Even the question is asked about definite integration, sometimes it is easy to calculate area using area. So you can go with that also, right? Let's encounter one more question. It is given that f of x equal to minimum of fraction, it is related to fractional part of x. So fractional part of x comma fractional part of minus x. So two functions they have given. One is fractional part of x and the other one is fractional part of minus x. So if you call this as f of x, now let us to call g of x, and this will be g of minus. What type of transformation that g of x and g of minus x will have means, if g of x is, for example, g of x is log x, then g of minus x will be, it will be symmetric or in mirror image with respect to y axis. That will be this one. So in the same way here, if you draw the graph of a fractional part of x, the fractional part of x graph is like this. It is 0 to 1, 1 to 2, 2 to 3, 3 to 4, 0, 1, 2, 3, like that you have it. And this is the graph of fractional part of x. Now if you want image with respect to y-axis, so image of this part with respect to y-axis will come like this, right? Image of that part with respect to that one will come this way, and this one. So blue colored one is the image with mirror image with respect to y-axis of this curve. So if you look at that this graph, you'll be getting like a like x shape lines you are getting in every block. In every block you have x. Now if you try to find out the minimum of this expression, so you want minimum means whichever the curve, when two curves are there, minimum means whichever that lower part is that, that is called a minimum. So if you observe that minimum 0 to half, half to 1, here 1 to 3 by 2, 3 by 2, 2. So green colored whatever I'm doing, I'm shading, that is the minimum value of this expression, of this function. So the original function will turns out to be, will look like this, and this is half, and this is also half, this maximum value is also half, right? Now what they're asking, if even not only fractional part of x, the minimum of a fractional part of x comma minus fractional part of minus x is also periodic. It is also periodic, and with a period is equal to 1. So after one length 1 only, the same graph is been repeated, the same part of the graph is repeated after 1 unit length. So since it's a periodic is 1, and the limits are from minus 100 to plus 100, so it will be 200 times. We have a property that at to bt f of x dx, if f is a periodic with period t, then it is b minus a times 0 to t f of x dx. So 100 minus of 100, 100 minus of minus 100, it will be 200 times 0 to 1 f of x dx. So between 0 to 1, what is the area of the triangle? Yes, just you can calculate a half into base is 1, height is half, so it is 1 by 4. So the value of the different integration is 1 by 4. So 200 into 1 by 4, the value is 50. Right. Let's look into one more question. Here, the question is tried little interesting. A strange question, strange way of approaching. Earlier, also in a JEE Advance, they asked this type of asking that maximum value of the function. Here, two variables you can observe it. That f of x is a function of x, and again the t is running between minus 3 by 2 to x. So t has a boundary x, and f of x is a function of x. So let us, in these type of cases, we have to rewrite the function. We have to rewrite the function. So here, let us introduce a new function g of t. Why this function is being introduced? Because the minimum, whenever, as and when, right from minus 3 by 2 to x, from as the function is, as the x is moving from as the t is moving from minus 3 by 2 to x, the moment the moment it reaches, as long as it reaches maximum value, it will keep on maximum. For example, I will for our understanding, I will tell you. Suppose for between 0 to pi, you take a sin x graph. 0 to pi sin x graph. So here, if I say that, g of x is maximum of, and this is suppose f of x equal to sin x graph. This is f of x equal to sin x. Okay, and I say that g of x is maximum of f of t, where 0 less than or equal to t less than or equal to x. Suppose this is the question given. So t is running between 0 to x. That means if as t is moving, so as long as it is increasing, the g also follows f. G follows f as long as it is increasing, because the moment it reaches a maximum point, it will maintain that maximum only. It will never come down. So once it reaches the maximum value 1, after that it will be flattened. The graph of g will be flattened. It will never come down. So the graph of g will be this green colored part. So this is what the meaning of a maximum of a given function. So let us name this g of t as this modulus of t minus 1 minus modulus of t plus modulus of t plus 1. See, if t is less than minus 1, that value of g of t can be like, if t is less than 1, if t is less than minus 1, then t plus 1 is negative. If t plus 1 is negative, obviously t is also negative. Okay, and t minus 1 is also negative. So all the three expressions are negative. So all the three expressions are negative. So everything, modulus of t minus 1 can be written as 1 minus t, and minus of, this is minus of minus t, and plus it is minus t minus 1. So simplifying, you are getting minus t. Similarly, between minus 1 to t, minus 1 to 0, between minus 1 to 0, if you observe that t plus 1 is positive, so this is a positive quantity. T is again a negative quantity, and t plus 1 will be positive. T minus 1 is negative, sorry. T minus 1 is negative. T plus 1 will be positive. So accordingly, you will be replacing that okay, value of a modulus of t minus 1, modulus of t plus 1, you are getting t plus 2. Similarly, 0 to 1. So if this can be observed in this way also. If you take the number line, so what are the reference points here? Plus 1, 0, minus 1. So if you take minus 1, 0, plus 1. So you are taking the four cases: first case, second case, third case, fourth case. This is what we are doing here. So in each of the cases, we are trying to redefine the function. So once you got the redefine the function, just you rewrite the function f of x now. F of x is between minus 3 by 2 to minus half, then it will be 3 by 2 only. Okay. If minus half to 0 is taken, f of x, then it will be 2 plus x. Between 0 to 2, this will be 2. So as per the definition of g, so here, but for x t less than minus 1, okay, and a t between minus 1 to 0, in each of the cases we are taking the maximum and maximum values of that, right? So we are taking the maximum values of that one, because the function is defined, f of x is defined as maximum of this. So accordingly, we got this all these functions over here. So now replacing that from minus 3 by 2 to 2, we have divided into three parts: minus 3 by 2 to minus half to 0, and 0 to 2. And you replace the function and you can calculate the definite integration, right? So this is how, observe that we have discussed one question. Very rarely they do ask, and very important to solve this type of questions. Even in previous AITS questions also, FITGI AITs also it is mentioned. It is given such type of questions. Okay, and here it is given. It is based on the fractional part of x. and before that we have discussed absolute value of x, where minimum of the function is taken, and here it is integral part of function. So if you are confident with these four functions, these three functions, so most of the questions in calculus, particularly integral calculus, you can do very well. Hope today's session will be very much helpful to you. Please subscribe to our channel, and and please follow our videos. I'm uploading more and more good videos which are very much useful for JE, IT JE 2025 and 2026. Please follow our channel. Thank you. Thank you very much.